right, we're going to look at 7.1, problem number 15. Variables x and y vary inversely. So we're saying y is equal to a over x. Use the given values to write the relationship with x and y and find the value of y when x is 3. So we're told x is equal to 5 when y equals -4. So the first thing we need to do is solve for the value of a. Thank you. You can put it right there. So we're saying our y value, -4, is equal to a over 5. Now at this point here, we need to multiply both sides by 5 to get a by itself, because that's what we're solving for first. 5 and 5 will cancel, giving us a by itself. And 5 times -4 is -20. So our equation is y is equal to -20 over x. So that's the first part of the problem, is to find the equation. Now we need to evaluate it when x is 3, or we need to find the value of y when the value of x is 3. So we plug it in. It's 20 divisible by 3. That's it. Questions on this here? I do not remember.
We haven't done it yet.
732?
Yeah.
Division.
Oh, we haven't completed it yet. We haven't got it.
We have a 7.3.1 and a 7.3.2.
And we're on which note sheet?
Did I miss a whole lesson?
There is. Where's the other? We did 732 on the first. So that was a week from Thursday.
The division, the one where you flip it?
Yeah.
And then make it times?
Uh-huh. There it is. I'm trying to remember, did we get to this one yesterday?
We're on 3.6, number 6, or 5.
No, we're on this one. Yeah, that one.
No.
You're talking about practice summer.
This is so. Oh, yeah, my bad, sorry.
You're good? Find the difference between these two here. So again, when finding the difference or sum of two rational expressions, the first thing we need to do is get the denominators to be the same. And to do that, we need to factor the denominators. So we're going to factor Well, we're going to have to factor the x squared minus 3x plus 2 and 2x minus 4. Which one do we want to do first? First denominator or second? So x squared minus 3x plus 2. Since there is no greatest common factor between these three terms, we can move on to our two sets of parentheses with three spaces. Since our third term is positive, the signs are the same and match the sign of the middle term. Minus and minus. Factors of x squared. X and x, and that's it. Factors of 2. 1 and 2. Now we can check this here to make sure x times negative 2 is negative 2x. Negative 1 times x is negative x. Gives us a middle term of negative 3x. So that's fine. So that's factored completely. Not what I wanted. 2x minus 4, how can we factor it? Greatest common factor of 2, yes. And if we factor it out, we're left with x minus 2. Now for us to be able to add or subtract, we do need to get the denominators to be the same. So we need to see what we need to do to get them to be the same. And kind of the method we did yesterday, we can look at these two and see what is the right denominator, our 2 times x minus 2, have, but the left one, our x minus 1 times x minus 2, doesn't. 2. It doesn't have the 2. So we're going to multiply 2 on top and bottom. Now we're going to go the other direction. What does the left side have that our right side does not? X minus 1. And now we can multiply these together. And we also multiply our numerators. The one from the top.
Yeah.
Thank you.
You're welcome. Now the left side, we can distribute the 2. 2 times 5x is 10x. 2 times negative 1 is negative 2. Now our other numerator we can distribute out. Negative 2x times x is negative 2x squared. Negative 2x times negative 1 is plus 2x. Our negative 1 times x is negative x. Negative 1 times negative 1 is plus 1. Questions on this here? Questions on anything we've done so far? Are you ready for the next step? Yes? Now the first rational expression doesn't simplify. I mean, it's as simplified as it gets. We can't do anything with it. The other numerator. All right, guys, let's focus in. Negative 2x squared and 1 have no common factors, but our 2x and negative x are like terms, and our 2x minus x gives us x, 1x. So we combine those like terms. Now, since we have everything simplified in the numerator and the denominators are the same, we can subtract our two numerators. So we're going to be subtracting our 10 minus 2x and our negative 2x squared plus x plus 1. We're going to be subtracting these two here. Now with addition, as we said yesterday, having the parentheses around both sets of terms isn't hugely important with addition. Subtraction, we do need to be careful, mainly with our second expression, the one that's being subtracted, because we do have to distribute that negative throughout the entire term. Because when we subtract our negative 2x squared, the negative and negative makes a plus 2x squared. When we subtract our positive x, it's the same as negative x. And when we subtract our positive 1, it's the same as negative 1. Questions on this here? Question on any of this so far? Now, the only thing we have left after this is to combine like terms and then factor if possible. When we combine our like terms, 2x squared, well, there are no other like terms with it. However, our 10x and negative x will combine to give us positive 9x. And lastly, negative 2 and negative 1 will give us negative 3. Questions on this here? Well, we need to see if we can factor 2x squared plus 9x minus 3. Most likely not, but we can check. Because the way we can check it is with our b squared minus 4ac. Because this is half of, well, not half, it's about a third of the quadratic formula. If this gives us a whole number, then it is factorable. Well, incidentally, it's still plugged in from earlier. And it gives us the square root of 105. Well, yes. And that's it. Questions on this here? We plugged it in, it tells us square root of 105.
Wait, how did you get from that to that?
This is our checking to see if it's factorable.
So it is factorable?
The square root of 105 does not work. Because it's telling us that our solutions for this would be irrational numbers, and so it's not factorable. Technically is, but we'd have to know the solutions to be able to factor it. Questions on this here? Questions on anything we've done so far? Ready for a hard one?
Oh my god. I've been chilling for about 4 days on my problem that we're throwing out. You too.
Oh, but then you're talking to me all
Let's
this.
Oh, the smiley face. I saw the smiley face. But what did it say?
Because because this is an object. The whole thing is.
What did it say though?
Can you not read? You might go back to second grade.
Order.
He,
This.
he's talking about the thing that's covered.
Order.
I thought there was something under it.
Oh my
I know, sorry.
Order. Front back. Order.
What elephant is out there? Did you hear that?
All right. Let's look at this one here.
Oh, Gargoyle's out there.
I want to be here.
John does.
All right.
He was
Let's look at this. So we want to be able to add or subtract. To be able to add or subtract these, we need the denominators to be the same. Okay. So we're going to have to multiply both sides, both of these expressions by something. Now with numbers, the what does one have that the other doesn't works all right, doesn't work great. But what is the first number we can turn both 4 and 7 into?
28.
28. And that would be 4 times 7 or 7 times 4. Now the reason that this works like this here is because is there a greatest common factor between 4 and 7? No. Because in fact, 7's primed, 4 is 2 and 2. So there's no common factor between it, so if we multiply, we're not going to have anything repeated. Is there anything else we need to multiply one of these two by? X on which one? 7, or 1 over 7. We're having to multiply top and bottom by 4x. Yep. And that can stay over there. Yeah.
That's a bug.
No.
Oh, it's working.
I dropped the pen, so I decided to throw it.
You want to look at least from Gargoyle?
Here we go. Let's multiply this here. 7 times 3 is 21. 7 times 4x is,
21. 28.
and we have our x. 4x times 7. 4 times, well, 4x times 1. 4x. Now, since we have the denominators in this the same, we have the denominators the same, and the numerators are as simplified as they get, we can go on and subtract our two numerators. Now that we have it set up this way, we can drop our parentheses, apply that negative to every term in our second expression, and we get this here. Now, before we say we're done, is there any way we can factor 21 minus 4x? Is there a greatest common factor between 21 and 4x?
Oh, 21. No. Because they're together. I thought you were.
Yeah, they're together. We can't, we have to factor something out of the 20x minus 4x to be able to simplify on top and bottom. But because we can't, that's as far as it goes. Questions on any of this here? Questions on anything we've done so far? How do we feel with these here? Do we want to see another example, or do you all want the rest of the time to work on homework?
Can you help us?
Yeah.